السلام عليكم ورحمة الله وبركاته. Today we will speak about the nuclear physics. Our goal is to define atomic structure, clarify the difference between isotopes, isobars, and isotones, define the normal radioactivity, distinguish the difference between alpha, beta, and gamma decay. We first start with atomic structure. The atom consists of nucleus surrounded by electrons. The nucleus consists of protons and neutrons. Protons and neutrons are known as nucleons. The protons inside the nucleus have the same charge of electron, but its rest mass is about 1,836 times the mass of an electron. The neutron is electrically neutral, and its mass is almost equal to the mass of the protons. There are three kinds of atoms: isotopes, isobars, and isotones. The first type is the isotopes, which are the atom of the same element having the same atomic number Z, but different mass number, like the three isotopes of hydrogen atom, H11, H12, and H13. The second type is isobars. The isobars are atoms of different element, have the same mass number A, but different Z number, like oxygen 816 and nitrogen 716. The oxygen and nitrogen have different Z number, but have the same mass number. The third type is isotones. Isotones are different elements having the same number of neutrons, like C614 and O816. The carbon 614 and oxygen 816 are example of isotones because they have the same number of neutrons. Normal radioactivity. The radioactivity is a process by which an unstable atomic nuclei lose energy by radiation. Three of the most common type of decay radiations are alpha decay, beta decay, and gamma decay. Alpha decay. The nucleus emits alpha particle loss, 2 protons and 2 neutrons. So the mass number decreased by 4 and the Z number decreased by 2. For example, for uranium, 892 and 238 converted to TH90, 234, and alpha particle. The number decreased by 2 and the mass number decreased by 4. Properties of alpha particles. Alpha particles consist of 2 protons and 2 neutrons. Alpha particle was the first nuclear radiation to be discovered. Beta particles and the gamma rays were identified soon after. Alpha particles are relatively slow and heavy compared with other forms of nuclear radiation. The particle travel at 5 to 7% of the speed of light. Alpha particles are unable to penetrate very far through a matter and are brought to rest by a few centimeters of air, or less than of tenths of millimeter of biological tissue. Beta decay. The basic process in beta decay converts a neutron into proton and an electron, or convert a proton into a neutron and a positron. Here, C614 converts to N714 and giving electron, which is negative beta particle. Also, nitrogen 712 can convert to carbon 612 and positron, which is positive beta particle. Properties of beta particle. Beta particles are high energy, high speed electrons or positrons ejected from the nucleus. Beta particles have a mass which is half of 1,000th of the mass of proton, and they carry either a single negative or positive charge. Their light mass means that they lose energy quickly through interaction with the matter. beta particles are much less ionizing than alpha particles and generally do less damage for a given amount of energy. They typically have a range of tens of centimeters in air and a few millimeters in material. Gamma decay. In gamma decay, no change in atomic and mass number. For example, here, the carbon C612, the carbon nuclei in high energy state. It dropped to or moved to ground state and release gamma rays. The properties of gamma rays. Gamma rays are electromagnetic wave of short wavelengths and high frequency. The wavelengths of gamma rays range from 0.005 angstrom to 0.5 angstrom. Gamma rays travel with the velocity of light and are not charged particles like alpha or beta rays. Gamma rays produce a fluorescence effect on the photographic plate. Gamma rays ionize gas they travel through, but the ionization produced is very small. Gamma rays are highly penetrating rays, and they are even penetrate than alpha and beta particles. For instance, can even pass through 30 centimeter thick air. Thank you.